Hey, Ethan. Just want everybody to know we're going to go over the quiz and one by one, we're going to go over the quiz. And as I told everyone before, as we get into deeper into the semester, it gets a little challenging. So just to let you guys know, I said that at the beginning, right? And when it first starts, it's also I'm here with you. So but when you're on your own and it's an exam, it's a little different. And everybody's going to find that out. But give me a second. Hey, Stevie, how are you? Excuse me. Hold on a second.
Good evening, Professor.
Hey, how are you, Batia?
Really good. Thank you for asking.
I'm sorry?
Really good. Thank you for asking.
Okay, great. How you doing, Alexis? Okay. 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 um, a lot of people had issues with the quiz. And we're going to go over it right now. Okay, the whole thing. Let me drive, and if you have a question, stop me. Right? Don't let me continue unless you are completely sure that you understand what's going on. Okay? So let's start. Hold on one second. Okay. So here, I'm going to talk about this. Okay. So this is, you have an investment account that started with $4,000 10 years ago, which has grown to 11,000. What annual rate of return have you earned? You've made no additional contributions to the account. Okay, so first thing we notice is that it's telling us what the present value was 10 years ago. Let's say it was 2011, and then it has grown to 11,000 in 2021. Right now we're solving for IY. Right, so, and I explained to everyone that when we have both in the calculation, the present value and the future value, the present value has to take a negative, has to be negative because the money is coming out of your pocket, right? So in this situation, we're going to say n equals 10, and we leave IY out of it because that's what we're solving for, right? There are no payments here. Payment is 0. Present value is negative 4,000. Future value is $11,000 positive, an absolute number. And then we compute for IY. Now, what I noticed, give me 1 second. Let me close the door here. What I noticed was the fact that some people were putting some outrageous numbers, right? There's no way that an account can grow from 4 to 11,000 with 30% interest, 40% interest. I mean, logically, we know those numbers are outrageous, right? And when you use numbers like that, you're not really thinking about the concept. You're not really thinking about it. But it can't be that much. It can't be that much. Now, another part of it says the investment account earns 17% per year from now on. What will the value be in 10 years? Okay, so now they told us it has grown to 11,000. So that's what we're going to our starting point, right? So, and then they give us a different amount, a different IY, right? Annual rate of return. So we're going to say N equals 10, IY equals 17, payment is 0, right? Present value is $11,000. And then compute for future value. And the answer is going to be 52,875.11. Another mistake and I'm telling you,
I'm sorry,
do me a
Professor.
favor,
Could you
whoever,
please
somebody has
repeat
the
that?
mic on, turn the mic off. Okay. Another thing I noticed is that the rounding, right? You got to pay attention to that, right? And round to 2 decimal places. Somebody answered one question, they put the answer and they put the percentage sign inside the box. That's wrong. That's wrong. You don't put the percentage inside the box. The percentage is already there. Round to 2 decimal point. They have a percentage outside already. You don't do anything. You just put the answer, but you put the percentage inside the box. It's wrong, right? And then another thing I noticed too, people are not using the calculator that I asked, because if you did, you wouldn't be making these rounding mistakes. And I am not checking these. It's not me checking this, right? It's not done manually. If I was doing it manually, then maybe I would not, when you put the percentage inside the box, I got it. And also the rounding, if you put 10.68, it should have been 10.70. I got it, you're close. But it's not me that's checking it. It's being done automatically. So you're going to get marked wrong. So I strongly suggest, wait, let me finish. I strongly suggest that you use the right calculator that I recommended. Yes, someone had a question.
Yeah.
Yes, Michelle,
In my other classes,
speak up.
we also use Pearson, and the teacher's like aware of like the rounding stuff, and
That's him.
um,
That's him. Okay, I'm just letting you know. I mean, you got to use the right calculator. I give breaks. I give a lot of breaks. Okay, let's continue.
Professor,
Yes,
I have a question
I'm sorry,
too.
could you repeat what you said for B? I missed what you said.
for which one, my
The
dear?
question before for part
Okay,
B.
this one right here?
Yeah, part B. Can you just repeat what you said?
Yeah, can you turn off your mics when you're done, because I'm getting echoes back, please. And when you have to speak to me, you can turn it back on. Okay, so now the account has grown, the numbers change, I guess. The account has grown from 5,000, from 1,000 to 5,000. So it says the investment accounts earn 13% per year from now on. What will the account value be 10 years from now? They're talking about this number. This number. The account has grown, right? So now it's N equals 10, IY equals 13, right? Payment is 0. Present value is 5,000, and then you compute for future value, then you're going to get 16,972.84. Okay?
Got it. Thank you.
All right. Now let's move to this one. This one I explained to everyone that you have to add 1 to the number. 1. So 34 is 35. Right? We talked about that. Right? So it's saying your 31st birthday and you're 65. So here, N is going to be equal to 35. You add 1 to it. Right? IY is equal to 8. Right? We're solving for payment. We skip payment. Right? And then we go right into, what are we doing here? We go right into future value, I believe, is 3 million. Present value is 0. And then compute for payment. You should come out to 17,410. Round to the nearest dollar. Round to the nearest dollar. If it's 410 or 409.97, you make it 410, right? You round it up. This is math. You're supposed to have taken a math class before you take this, right? And everybody knows the rounding. Now, when you go for a job, I'm telling you, the rounding is very important because these numbers are going to be like 300 million and 30 million and 50 million, 70 million. And the rounding has to be just right. Because if you're going to decide to make your own rules, if you're going to say 0.003 times 300 million, it's a lot of money that you're losing for the company. Does everybody understand this? Can I continue? Okay. Yes, so
Professor, I have a question.
okay.
Okay, can you go back how we have done this calculation on the retirement, because I'm not coming up with the number.
Okay, it changed the number. Okay, so this number, 21 minus 65 is 44, right? 65 minus 21 is 44. You add 1 to it. So that means n equals 45. Whatever this is minus this birthday, right? Let's say this was 25, right? Then the answer would be 34, but you add 1 to it, something like that, right? You add 1 to it. Whatever the net number between those two, you add 1 to it. So n is going to be equal to 45. IY is going to be equal to 10%. We're solving for payment. Present value is 0. Future value is 4 million. Compute for payment. And you should come up to 5,564. And round to the nearest dollar. Okay, so this is a growing perpetuity, right? A growing perpetuity. The formula for a growing perpetuity, right? Right? The formula for perpetuity, right, when you're doing it this way, is the amount, cash, rate minus growth, right? So it's going to be 4,000.11 minus 0.02. So this is going to be 4,000 times 0.08. That's why it equals 444. So this is growing, right? So you're going to say 4,000 times 1 in parentheses, 1.02, right? And then divided by 0.11 minus 0.02, and you're going to come up with this number. Right?
So
One
the
more
first
time.
one,
Let me finish. One more time. 4,000 divided by 0.11 minus 0.12. Rate minus growth. And then here, you're going to say 4,000 times 1.02 divided by 0.11 minus 0.02. Yes, Michelle?
never mind. Thank you. You answered it.
Okay. All right. Now, again, one of the things that I saw, right, was that I saw a lot of mistakes that were like, I couldn't believe because it didn't make sense, right? It didn't make sense. Okay. So here, let me do it and then we'll go over it, right? N for the first part, N equals 43. IY equals 10. Payment equals 5%. present value is 0, and then compute for future value, you're going to come out with this amount. Okay? Now, for this part, you're going to say N equals 43. Payment is 0. IY is 10%, right? Future values 2,962,003.46, and then compute for present value. That's this amount right here. Here on C, right? N equals 20. It says it wants to know if you take 20 payments of this, how much are you going to be getting? So here we're going to be solving for payment. So N equals 20, because right here we have the amount of time, right? 20. We know the interest is 10%, IY is interest. We leave payment alone. Future value is 0. We already have the money in our hand. It says starting 1 year after retirement. That means you got paid already. So the money's with you. So that's the present value. So the present value is 2,962,003.46. And then compute for payment. You should come out to 347,915.81. Right? The second, the D now is saying, suppose instead you decide to withdraw 300 per year in retirement, right? What would end the number of periods would you have, right? So here's what we're going to do. We're going to say, we're going to leave N alone, right? IY equals 10, right? Payment is negative 300,000. Negative 300,000. Future value is 0. Present value is 2,962,003.46, and you should come out to 45.84. Last one, right? Now, someone answered this question and they put a percentage sign in here, inside the box. That's going to be wrong. That's going to be wrong. If I was marking the paper, that's different. But it already has a percentage sign outside. They put it inside here. So that's going to be wrong. So in this one, we're solving for the interest rate. The interest rate. So we know that in this situation, N equals 43. We leave the interest rate alone. Payment is negative 1,000, right? Present value is 0. What I expect to have in the future is $1 million. And then I compute for IY, and I'm going to come up with 11.74. Not inside the box. Not inside the box. 11.74, and that's your answer. The mistakes people were making, right? And I say this all the time, is in the rounding or putting a number that is totally astronomically impossible. You're not thinking about it. Okay, so you've purchased a car. When you purchased a car, you took out a 5-year annual loan payment, right? With interest, a 6.4, right? The payoff. So let's do this together, right? You're going to say N equals 4. IY equals 6.4, right? Annual payment is 5,100. Future value is 0, and then compute for present value. When you buy a car and you need the payoff amount, this amount is the amount with interest. If you're getting a payoff amount, you're not going to be paying interest on something that hasn't accrued interest yet. So you're going to get the present value. Here, yes,
I'm sorry, you said N was 4. Is
yes,
it,
and it's 4.
it's not 5? It says 5-year annual payment.
What does this say right here?
My bad.
You have the car for 1 year. There are 4 left. So N is 4. You get it?
Yeah.
Okay. Now let's do the other one, the last part. The last part is N equals 1, IY equals 6.4. Payment is 5,100, right? Future value is 0, compute for present value. And that's 4,793, spot 23.
So the only thing that changes here is N.
Right, 1 is 4, 1 is 1. When you buy a car, for instance, you went into the dealership, you bought a car, and you bought a car, and they gave you a 5-year loan. After 1 year, you decided that you did not like the car, and you want a payoff amount. In other words, how much do you owe to get rid of it, right? And that's your payoff. This is what they mean by that. You've had the car 4 years now, and there's a year left. How much is that payoff amount? That's what this is. Okay. This one is a very tricky question, but I was very surprised that quite a few people got this right. Quite a few people got this right, right? This is a perpetuity formula. However, it's rate minus growth. If the growth is declining, that means it's a double negative, then you add it. So it's going to be 1,000 divided by 0.02 plus 0.05. There are no subtractions here. It becomes a double negative. This right here becomes a double negative because it's declining. Rate minus growth, it's already negative. So if it's declining, you're going to put another minus. So then you're going to add it. So it's going to be 1,000, right? Divided by 5.05 plus 0.02. So it's 1,000 divided by 0.07. And that's the answer. Right? Rate minus growth, but it's declining. So you got to add it, a double negative. Okay. This one also, people were putting down all kinds of different numbers, right? I explained that a lot of people that are wealthy, pay their mortgage once a year, not monthly, right? Once a year, they make a payment and that's it, right? We're going to get to monthly mortgages. I believe in the next chapter 5, right? That's a monthly, right? And then when you do a monthly, your calculations for monthly has to be reflected in the number of periods also. But we didn't get there yet. So you buying a house for 300,000 and you put 43 down. So we're financing 257 for 30 years at 9%, right? So N equals 30, IY equals 9. N equals 30, IY equals 9. Right? We're solving for payment. So we skip payment. That's what we're computing for. Right? Future value is 0. And then present value is 257. And then compute for payment. Round to the nearest dollar is 25,015. Not $2,000. It can't be 2,000. How can it be $2,000 for the annual payment? It can't be 75. What is? I saw another answer. $3,000. It can't be. Can't be. Impossible. Right? Logically, it's impossible. Okay. This was the balloon payment, right? At the end of the 7 years, right? This was the balloon payment. So N equals 7, IY equals 4, payment equals 6,000, right? Present value is 0, compute for future value. And you should come out to 47,389. Round to the nearest dollar.
No.
What happened?
See, this one comes out to 0.77. So if you round it to the nearest dollar, it's 390.
Would it accept 390? Yeah, it would accept 390.
Oh, never mind then. All right.
Please turn off the mic.
What are the present and future values?
It's only future value here. Payment N equals 7. IY equals 4. Right? Payment is 6,000. Right? Present value is 0. Future value, that's what you're computing for. You have a loan outstanding, requires making 7 annual payments each at the end of the 7 years. Your bank has offered to allow you to skip making the next 6 payments in lieu of making 1 large payment at the end of the loan terms in 7 years. If the interest rate on the loan is 4%, what is the final payment will the bank require you to make so that it's indifferent to the 2 forms? Right?
God, is there a question like this where it's opposite, so you have to do the balloon payment at the beginning So the future value is 0 instead of the present? 'Cause I feel like
I don't know that. I don't. What do you mean the future of the balloon payment? I don't get it.
basically instead of doing like the big payment at the end of the 7 years, you would just like, do it in the beginning or something. I feel like I saw a question like that.
So why would you do that? You would need to borrow it if you have it.
Never mind.
No, I'm trying to understand what you're trying to say. So wait a minute. Which way is you mean if the bank had the money or which way, Michelle?
No, I was probably hallucinating. I thought I saw a question like that, but never mind, because it doesn't make sense.
Okay. Okay. So this question is what we see all the time, right? It's an endowment. Okay. And the endowment is for, it wants to pay $7,000 a year forever. And the way you calculate that is that you're going to say 7,000 divided by 0.09. And it comes to 77,777.78. And every year, if you say 77,777.78 times 9%, you're going to come out to 7,000 per year. That's what this means. And as long as this amount is in the bank or in a financial institution, it will pay out this $7,000 forever. And that happens all the time. Forever and ever. Right? That's why people who are wealthy, when they donate money to foundations, this is what basically what this is. Okay. This question was like this, right? You want to endow a scholarship that will pay $14,000 per year forever. Okay? So 14 times 0.08, 14 times 0.08 is 175. Now, your answer to change if you endow it now, but make the first award to a student 10 years from now. When you do this, you start at 0. You start at 0. So which means that it's going to equal to 9, right? So N equals 9, IY equals 8, right? Payment is 0. Payment is 0, right? Future value is 175, and then compute for present value. And it should be 87,543 spot 57, right? All he's saying is that I don't want this to start till 10 years. How much money do I have to give up right now? So in that, that's from 0 to 9, because that's how you're calculating it. And on the 10th year, we'll give the money out. What do I have to do? And they said, okay, so donate 87,543.57. And then in 10 periods, in 9 periods, it's going to grow to 175. And when it goes to 175, at an interest rate of 8%, it will pay out $14,000 forever. That's what this is saying. Yes.
Sorry, could you repeat this second part here? How'd you get the 87,000?
How to get what?
How'd you get the 87,000?
Oh, yeah. Okay. So what happens is when you're for endowments, right? You start at 0. That's why when you do your calculation, it's not 10 years, it's 9. So it's 0, and then it makes the 10 years 0, 1, 2, 3 to 9. So it becomes 9, right? So n equals 9. N equals 9. IY equals 8%. Payment is 0, right? Future value. Future value is 175. And then we compute for present value. And then you're going to get 87,543.57.
Okay, thank you. I think it was the year that
Okay.
slipped me off.
Excuse me here?
I think it was the year part.
Right, right. And that's why I remember I made that very clear last time. I said it's from 0. Even I believe it was Michelle that asked me that. And I explained that. Right? One of the things that if I was taking this class and I was on the other side, sitting on the other side, all these little knickknacks, or I would take notes on them, right? And make the notes clear so you understand them, right? The worst thing is to write something and you don't know what the hell it is, right? You're trying to say, oh my God, I don't mean to use that word, but you say, oh my God, what is this? I don't even remember writing this. But if you write clearly, and if it makes sense to you, then you remember, right? Then you remember. This right here, this endowment, this has to be 9 when you do the present value of this, right? This has to be 9. And then all the guy is saying, or the person, the lady or the male, is saying, what amount must you donate to endow the scholarship? How would your answer change if you endow it now but make the first award to a student 10 years from now? Okay, so we're going to just give me the present value. And I can put this money in. And then when it gets to this, right after 10 periods, and then we'll pay this forever. Any questions here? Okay, one more thing. Yes, Ethan.
Oh, sorry. It was
Oh, Michelle. I'm
Um,
sorry.
If you have a problem with both future and present value, does it matter which one you make negative? Like, let's say you're not sure.
Not really, Michelle, but to keep it the way it's supposed to be, always remember when you're paying something at the present, it's coming out of your pocket. Do you know what I'm trying to say? You're losing it for future value, right? If I say to you, if you're going to the bank and you're going to put $5,000 in the bank and to take it out in 20 years, that money's coming out of your pocket. So it's a negative,
Got it. And what will
okay?
constitute a positive payment versus a negative payment?
Huh?
What will constitute like a positive payment versus a negative payment?
Positive payment is what you get at the end. A negative payment is what you start with at the beginning.
I mean, like the monthly payments or the annual payments, like the PMT variable, not the.
You say that one more time. You guys speak just a little louder.
Mm-hmm. And the payment variable, like PMT, what we have every month or every year.
Uh-huh.
Like, let's say saving money every month, or would saving money be negative because I'm like I don't have
Yes.
it? No.
Yes. When you're paying it, yes, it will be a negative. And then at the end, when we get paid, it's a positive number. Yes, because we're losing it.
Got it.
Absolutely. Good point. But when it's paying out, oops, hold on 1 second. I just went blank here. When it's paying out, it's different. then it'll be positive. Right? Like what we did on the on those in the retirements, right? When they're paying out, those are positive, I believe.
It's like withdrawal.
I didn't, you broke up.
A withdrawal would be positive then? Like after you retired, basically?
Yeah, 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 yeah. And then also how we would exhaust the money because we're getting it. Yeah, we could say that. That's why we put a negative. We'll talk about this a little bit more. I have to see it. That way I can explain it to you. But definitely that can happen. Right? Something paying out to you and then you paying into something. It's two different ways coming out. That's a positive to you. But when it's coming out for you to get money in future date, it's a negative. Okay. This question, I would say about 60 or 70% of people got this wrong. Okay? Now, let me explain something to everyone. Right? You have to take the values for each payment. For each payment, not just one. I saw that. A couple of people did that. And I explained to you, if this is wrong, this is going to be wrong. Okay? So let's do this together, right? And let's get this right. Okay. So you have just received a windfall from an investment you made in a friend's business. She will be paying you $31,421 at the end of this year, $62,842 at the end of next year, and $94,263 at the end of the year after that, which is 3 years from today. So the first one, you're going to take the 31,421. As I said, you're going to hate me or whatever you want because I'm going to sound like a broken record. That's an old thing. You guys probably don't know what I mean by that. But anyway, or a CD that skips. Okay, it keeps going over the same thing. N equals 1. IY equals 9.7. Payment is 0. Future value is 31,421. Compute for present value. Now you have one of them. The second one, N equals 2. IY equals 9.7. Payment is 0. Future value is 62,842. Compute for present value. Now you have two payments for year 1 and year 2. Now you need year 3. N equals 3. IY equals 9.7. Payment is 0. Future value is 94,263. And then compute for present value. If you add all of the present value for N for year 1, year 2, and year 3, you're going to come up with 152,266, round to the nearest dollar. Now, once you have this number, you need to take the future value of it, which is N equals 3, IY equals 9.7, payment is 0, present value is 152,266, compute for future value. And then you're going to come up with 201,012, round to the nearest dollar on both. That's it. This is on the test. I'm telling you right now. This is on the exam. Okay? So remember. Yes, Michelle. Oh, Sabrina,
Yeah,
what did
Professor,
you say?
can you please repeat?
I can't hear you, my dear. You have to speak up.
Can you please repeat B? I'm sorry.
The B part?
Yes, thanks.
So the B part is n equals 3. Because it says, what is the future value of your windfall in 3 years? Right? So n equals 3. IY equals 9.7. Right? Payment is 0. Present value is 152,266, and then compute for future value. And that's how you get the 201,012. Now, class, are there any questions that we've gone over on quiz 4 that you are not sure of or would like me to go over? So right now, everyone is telling me that they understand everything now. They got it now. Okay. All right. I wanted to start with chapter 5. Give me 1 second. I want to see what I have for that. Give me 1 second, class. Okay, can you see this?
Yes.
Okay. So we're going to be doing interest rates. Okay. You have APR, annual percentage rate. You have APY, annual percentage yield, which we're not going to be touching. EAR, effective annual rates. We know about future value already, right? We know about cash flow. We know about compounding. I explained that to you about the interest, how interest gets interest on interest, and that's why it grows so fast. We know about N, which is data of the last cash flow and stream cash flows, right? So the number of periods, right? Present value, and then interest rate or discount rate for an nth year term. So which means that you use the exponent in the formula. So basically, it's like when you have a credit card and they have what they call a EAR and an annual, and the way it's calculated on a daily or a monthly or every 6 months. Those are the kind of interest rates that we're going to be dealing with. And then also keep in mind, right, when I'm going to be showing them to you, we're going to look at the formulas, which is very important. The formulas are very, very important in this case because those are going to be your bread and butter when you're going to explain them, right? And when you're going to have them in your problems, right? The EAR, the effective annual rate, right? Which is what the real rate is, right? When you go into to get a credit card and they give you effective annual rate, it's a little higher than an annual rate, right? That's why a lot of times people have a hard time calculating their interest rate on their credit card. Sometimes it's daily. That's why it's so high. Sometimes it's daily. I don't know if you guys noticed, at one time, if you loan money at 20%, that was considered illegal. That was like a loan shark. Now you have credit cards up to 27%, 25%. And then in some states, you can't do that. So the way the credit cards do it is that they go into another state. And then when you apply, that state allows that state allow credit cards to charge 27%. So when you get the credit card, you're not getting it from the state that it's illegal, you get it from another state, but you still can use it in any state. So it's very hard to understand how those things work, but they're loopholes. And you have like in Sioux Falls and Delaware, where they can issue cards at a higher rate. New York can't do that. Some states can't do that. But yet you can get the card from those states and pay those rates, right? But the state that it's illegal to do it at that rate can't issue cards. So one of the things you have to understand is the effective annual rate, right? So which indicates the total amount of interest would be earned at the end of each year, right? So you got the small one where I believe it was Michelle that asked me that question about the effective rate. We were talking about that, the compounding, right? So you have like on a yearly basis, if it's 5%, you're going to earn 105. And then the following year, you're going to earn interest not on 100, but you're going to earn interest on 105 squared, right? Which comes out to 110.25, right? Those are the kind of things, that's how it works with the interest. And if you were to multiply this, square this, you'll come out with this number, which is the same thing, right? So one of the things we have to understand is that when we do an EAR, right, and we're trying to calculate interest like 6%, and it's monthly, right? In our calculator, we have to convert. We have to convert the interest. And the way we do that is when we do the IY, we're going to say 6 divided by 12. And then this is going to be our interest rate. So for instance, if we bought a car and it's at 6% monthly, and it's for 48 months, each month, this will be the interest, right? And the way we're going to put it in our calculator, we're going to say N equals 48 because we have to match the interest. We have to match the interest to the number of periods, right? So we're going to say N equals 48. IY equals 6 divided by 12, which is going to give us this interest rate right here. And if you go on your calculator, you say 6 divided by 12, you're going to get this. Now, what happens is you have to have your calculator set for 6 places. That way your rounding is right, right? Your answer's not wrong. And then once you do that, right, once you do that, this will be a loan for 10 years because it adds up. Hold on. It adds up to 120 months. Yes, Stephen.
No, Professor, it's me. When I try to divide 6 by 12, it's giving 0.50 instead of 0.48.
You have to adjust your calculator 6 places. Do you have one of these?
I did it, yes. I do have the same
So you
B.
have to adjust. There's no way. It comes out to, it could be 5. It could be 5. It could be 5. You're right. It could
It's
be
coming,
5.
0.50, it's coming.
It
Yes.
could be 5. Yeah, it could be 5. It could be 5. Yes. It could be 5.
Thank
All
you.
right. It could be 5. So, but this is just showing me the calculation, right, on a monthly basis. Hold on. Let me finish this. It could be 5. Now that you say that, I'm thinking about it. It could be 5. So when you're doing this, right? When you're doing this, we would do it this way. But what we would do, we would say 120. This would be a 10-year loan. We would say 120 because we have to convert 10 years into months. So 10 years is 120 months. And then we would say 6 divided by 12. We would have a calculator for that. And then present value is 0. And then we're trying to calculate the payments. Future value is 100,000, and this will be our number of payments, right? This will be our number of payments. I want to show you another one. Now, everyone, these are the effective annual rates, right, when we do our calculations, right? This equals 1 year. This equals semi-annual. This equals monthly. And this equals daily. Please look at these formulas and write them down. Take a picture, whatever you want to do. But these we're going to be using religiously. So if this was 12, this becomes 0.12, right? Because we moved the decimal place 2 places and converted. And we do the exact same thing here to come out with these answers for these formulas. Okay, here. This is what I was talking about, right? Are you there?
Yes,
Hello?
yes, Professor.
Yes.
Yes.
Now we got it right here. Okay, good. We got it right here. So in this one, this was the course of leasing system for 48, right? This is how number of periods, right? It's 48, and the interest amount is monthly, right? So we're going to say I'm sorry, 5 divided by 12, and then the payment is going to be negative 4,000, and then you calculate for the present value, right? But the point I'm trying to make, and I want everybody to understand, is that this right here is very important. This is what we're going to be using. And the monthly has to reflect, the number of periods have to reflect the interest. So if we're paying yearly, it has to reflect on a yearly basis. If we're paying monthly, it has to reflect on a monthly basis. If we're paying twice a year, it has to reflect that way. And a daily has to reflect the same way. I don't think we have anything for daily. I think 6 months and here, and then probably here. All right, so let me show you a couple of questions on the homework. And then I'm going to show you the formulas. And then we're going to do a couple of them. I'm not going to assign any homework until we've gone over this. And this is our last chapter that we're going over until this is our last chapter, and then we go into our midterm. All right, so let's do this. I'm going to stop right here, and let me go into the share application. Okay, can everybody see this?
Yeah.
Yes.
Okay.
Yeah, we can see it.
All right. So let me show you this. It says your bank is offering an account that will pay 20% interest, an effective 2-year rate in total for a 2-year deposit. Determine the equivalent discount rate for the following. So let's start with the 6 months. Let's see how that looks. So for the 6 months, let me explain that. How many 6 months are there in 2 years? There are 4 of them. There are 4 of them. So right, there are 4 6 months, right? Each year has 2. 2 years have 4, right? So now it's asking me to calculate the discount rate. So this is the formula, right? It's going to be 1 plus the interest, which is 20%, right, for 6 months, and then the exponent of 1/4, which is 0.25, right? This gets converted into you convert this to 0.25, right, a decimal. So 1.20 and the exponent of 0.25 minus 1 equals 0.04688. And of course, you move the decimal place 2 places, it comes out to 4.66. Okay, that's for the first one. The second one, it says for 1 year. Now, this is a 2-year period. So 1 year and 2 years, there are 2 of them. So half, right? So we're going to say 1 plus 0.20, right? The exponent of 0.50 minus 1. And then you move the decimal place 2 places, then it becomes 9.54%. Now it's saying to you for 1 month, right? So 1 plus 0.20, 1 divided by 0.24, the exponent of that, right? And then minus 1, you're going to come out to 0.763. You move the decimal place 2 places, 0.763. Yes.
So in the textbook, when we were looking at the EAR formulas, the exponent was the whole number. So like, let's say,
Not there yet. This is something different. We're going to get there.
so what's the difference?
Right. It's a different formula. That's why I tell you, the book doesn't show you this one. That's why I'm showing it to you now. Right. And I explained that from the beginning. There are some things that I have to show you, right? Because it will take forever trying to do a lecture on it. This is much easier showing you this way because I'm showing you the formula and I'm explaining to you how it works, right? This is much easier doing it this way, right? This right here, what we need to know are this formula right here in the nth period, which was in the lecture, but they don't really show you too much on that. Okay? Yes? Yes?
Professor, how we can do this calculation on the BA2 plus calculator?
Right. There's an exponent feature there.
Can you give us a demo for
Not
this,
yet.
please?
Not yet. Let me finish. Let me finish. I'll tell you what it is. Let me finish. All right? Let me finish. All right, hold on. Let me finish. Okay. One by one, I'll just finish. One thing at a time. Okay. So in this situation is where is Michelle there? Michelle?
I'm like disconnected.
Can you see? You can't see?
Not a
Okay, because this is the EAR right here. Okay, from what I was talking about. So you're considering 2 ways of financing a spring break vacation. You could put it on your credit card at 18% compounded monthly or borrow the money from your parents. You want an interest payment of 10% every 6 months, which is lower. So on the first one, we're going to calculate the APR, annual percentage rate. It says it right here, right? And this is the formula that we were talking about for 12 months, right? Compounded monthly. So 0.18, this is converted into a decimal, move the 2 places. 0.18 divided by 12 plus 1, the exponent of 12, which is monthly, minus 1. And the answer is 19%, 562, 56, round to 2 decimal places. The second part is they are giving us the interest rate. They're giving it to us, right? So all we have to do is do it for semi-annual, right? Which is every 6 months. So the exponent is 2. So 1 plus 10%, the exponent of 2, right? Which represents 6 months, minus 1, which is 21%. So it's better for you to use your credit card than to borrow it from your parents. That's what this is saying. Right? Yes.
So can you explain to me why the exponents were 12 and 2 for the both parts?
Right. This one is the annual percentage rate, right? I showed you that the last, when we were doing the lecture, right? This right here is the exponent of 12. This represents annual percentage rate compounded monthly. This represents the monthly, 12 and 12. This right here, they're giving us, on the second part, they're telling us how much the exponent is. They're telling us the credit card amount. Right now for loan substitute, right, by 2 because we're provided with the 6-month rate, not the annual rate compounded semi-annually. They're telling me what it is. They're telling me what the rate is. It's not compounded. So every 6 months. So I'm doing this. I'm doing 1 plus 10, right? The exponent of 2 minus 1 is 21%. That's the formula for the EAR for semi-annual. Because there are 2 semi-annuals in 1 year, right? 6 months and then 6 months. Okay. I am not going to assign this. I want to go over this. There are a lot more to do with this. And everybody's going to get it. All you guys are going to get it. I mean, right now, it's new to you. And, just like everything else, we'll get through this. We're going to get through this. All right? So we got through quiz 4. This is our last chapter. And then after we finish with this chapter, we'll do a review. And then we'll have our exam. All right? So on that note, I will see you guys on Thursday.
Professor,
Yes. Yes?
do you know what day like the midterm will be on so I can put it on my calendar?
I don't know yet, my dear.
Okay, thank you.
Okay.
Good night.
Good night, my dear.
Professor,
Good
have a
night.
night.
Yes. Take care. Take care.
Hello, Professor?
Yes. I'm here. I'm here. I'm going to talk to you.
Okay.
Professor, in the next class, you're gonna teach to use the calculator for this, like, because I don't know how to do it.
I'll show you how to do it. Don't worry.
Thank you.
Malik,
Yes.
did you notice that, let me bring up this is quiz 4, right?
It was for chapter 4 homework and quiz 3, chapter 3 quiz.
Okay. So chapter 4 homework. So let's go over that. So let's start with quiz 4. You okay with quiz 4?
Quiz 4, I wasn't able to review my answers because it says that the deadline was it was still a
No, you can review it. You can review it. Okay. So let's start with quiz 3. Okay?
Okay.
Let me bring up your work. Okay, hold on. Let me take everybody out. It's just be you and I in here.
Okay, no problem.
Okay. So it's just you and I. Okay. So let's look at this. Okay. This is yours, right?
Yes.
Quiz 3. Now, you were talking about which one?
This one.
5?
Yeah, all the answers that I
Okay. So this is what you've done. You did this, and it says you answered 80 million. The answer is 80. It says round to 1 decimal. The answer is 80. 1
So-
decimal. You put 80 million. That's wrong.
Okay.
All right. So let's do the same thing here. You put 90. It's 90.0. Okay.
Yeah,
Round to 1 decimal.
I see that one now.
Okay. Now let's see the other one. You answered 0.87. The answer is 0.09.
For this one, I didn't see that.
And you
on the
answered
screen.
76,860. That's what
Yeah.
you answered.
I see the wrong in this one, but it wasn't showing me that on my end. It was just showing me that answer, so I was assuming that's what I had put. In.
No, that's not what your answer is. This is what you answered. All you do is clip on this little red thing. It tells you what you answered. Okay?
So
That's what you put down. You put too much.
Mhm.
Okay, now which one again? What, you had something else now?
No, I was gonna say, was that the case for all of them?
Yeah, you put down the wrong thing. You put down the wrong. Let's look at another one. Let's go back to another one. Let's look at quiz 4. Okay, this is you right here, right?
Yes.
Okay, let's look at question 3. You answered 13,122.
Yeah, so I definitely see it now. Because on my end, when I was viewing it, it
You know
was
what you
looking
did?
like
Look at this one. You put the percentage inside the box. You and a couple of people did that. The percentage is already out here. You're not supposed to put the percentage in there.
Mhm.
Let me just finish. Here, you answered 333,333. That's wrong. The answer is 14,286. And let me just finish. And in the windfall, you answered 128,059, and the answer is 131,315. Okay?
yeah, I see
got
where
it
the
now, right?
confusion is coming from. Yeah.
Yeah, okay.
Because when I was viewing it on my end, I was confused because when it was showing me my answer,
The right
and
answer, right?
the right answer, so I was assuming that I had the right answer, but it looked like
Mm-mm.
a glitch.
All you have to do is click on that little red spot. That means you got it wrong. And it'll tell
Yeah,
you what you've done.
it
Okay?
it definitely makes sense now. So I see it much more clear, and then I'm
Yeah,
definitely gonna try to avoid making the silly mistakes like putting the percentages in the box.
and that's what I was telling you before. Remember? We talked
Yep.
about that.
You definitely
All
told me.
right?
Yes, thank you for taking the extra time to stay with
Absolutely.
me.
Absolutely. Have a great evening.
You too, Professor. Thank you. Have a
All
good night.
right.